Hello, my name is Jack Evans and I'm a PhD student studying healthcare technology at the University of Exeter. Today I'm going to be presenting initial work on how we can use VR to examine fine performance differences in upper limb movement, and we eventually want to use this method to assess and classify upper limb impairments in patient populations. So, successful coordination of our various joints and muscles is vital for everyday upper limb function. Circle drawing involves multi-joint control, and it might be a simple but effective method of studying upper limb movement in patients. Prior to doing this, it's important for us to test and validate the method with healthy participants. So what I'm presenting today is how a remotely administered virtual reality circle drawing task can detect these sort of fine differences between dominant and non-dominant hands in healthy participants. Now we know that there are these subtle performance differences when completing tasks with the two different hands, and so if our method can detect these differences, then it may be suitable to detect or classify sort of fine differences between different impairment levels in patients. So to test this, I designed a virtual reality application for the Oculus Quest VR headset, which contained our experiment, and I uploaded this to a website. And we invited people across the globe who had access to an Oculus Quest headset to download the app and complete the experiment remotely. The experiment itself was repeated measures design, and it consisted of a circle drawing task where the participants were asked to trace the outline of a free-floating circle with their dominant and their non-dominant hands. And there were 32 trials in total, sort of 16 for each hand, and one trial consisted of a single revolution around the edge of the circle as fast and accurately as possible. And we collected hand kinematics during the task through the controllers that come with the Oculus Quest. So we collected data from 34 participants in total, and performance was assessed on a range of kinematics like velocity and movement time, path length, and circle roundness, which is essentially how perfect participants are able to draw a circle. And we sort of compared this data using a series of paired sample t-tests and Wilcoxon-assigned rank tests, and we found some pretty interesting results. There were these very small but significant differences in velocity, movement time, and path length, where people tended to use slightly slower and longer paths when using their non-dominant hands, but the roundness of circles wasn't different between the two groups. So our implications from this are that hand use doesn't affect circle drawing ability, but it does affect how you draw the circle. There seems to be some sort of speed-accuracy trade-off going on. The primary aim of the study was to see whether we're able to detect these fine motor differences using this VR-based circle drawing task. And the differences we were able to find are sort of small but significant, which indicates that this method might be suitable for assessing impairments in patient populations. So our next moves will be working to test this method in people with upper limb impairments, and we'll also be using a bit of patient and public involvement to try and develop some feasible and useful assessment tasks for clinical use. Thanks.